Let Ort Z denote the group of automorphisms of a group G. Which of the following is not a cyclic group? Before solving this problem, first we have to recall some facts related to this problem. So we know that Ort of Zn, this is isomorphic to Un, and order of Ort Zn equals to phi n. Third point is u p raised to the power n isomorphic to z p raised to the power n minus p raised to the power n minus 1 u 2 raised to the power p isomorphic to z2 cross z2 raised to the power p minus 2. So these are few facts related to this problem. Option A saying Ort of Z4 from fact number 1, this is isomorphic to U4 and U4 is set containing elements 1, 3. This is a group of 2 elements, 2 is prime number, so group is cyclic. Group of prime order is always cyclic. Similarly, option B, Ort of Z6 isomorphic to U6, elements of U6 are again 1, 5. This is again group of prime order, so cyclic. Now come to the option C, Ort of Z8, this is isomorphic to U8, this can be written as U2 cube, and this one is isomorphic to from last one. Using this one, this is isomorphic to Z2 cross Z2 raised to the power 3 minus 2 means 1. Z2 cross Z2, and we know that it is not cyclic. What is the condition for cycle? Zm cross Zn is cyclic if and only if GCD of Mn equals to 1. That's why this is not cyclic. Not cyclic, and it is asked, so it will be right key. Now come to the option D, Ort Z10. This is isomorphic to U10. Elements of U10 are 1, 3, 7 and 9, and this is group generated by element 3. You can check that each element can be written as power of 3. You can apply modulo 10 also. This one can be written as 3 raised to the power 0, 3 raised to the power 1, 3 square, and this is 3 cube. So each element can be written as power of 3. That's why option D is cyclic.